Greetings, this is Dr. Dan with Optimal Optics, here to answer two questions dealing with Unit 1, the electromagnetic spectrum. Now remember, this is an optics course, it is not a math course. If you have difficulty understanding the math, I suggest either going to the Khan Academy online, or I am a math tutor, and you can contact me and you can get one-on-one math tutoring from me. Question 1. If an alien Death Star destroys our sun, how many minutes later will Earthlings realize that the sun is no longer there? Round your answer to the nearest tenth and assume that the sun is 150 million kilometers from the Earth. So to answer this, we have to recall the distance formula that we all learned in junior high school. Distance equals rate times time. Now the problem is asking for time. So we're going to rearrange the furniture, divide both sides by rate, leaving time being equal to distance divided by the rate. Now we're given a distance of 150 million kilometers. That's an awful lot of zeros. So let's convert that to scientific notation. Count the spaces from the 1, and we have 1.5 times 10 to the 8th kilometers. The speed of light, which equals the speed of all of the electromagnetic radiation, we found in Unit 1 to be equal to 3 times 10 to the 8th meters per second. Now we have distance in kilometers, we have rate in meters per second. We can't have that. We either have to convert them both to meters or both to kilometers. Let's convert the kilometers to meters. Becomes 1.5 times 10 to the 11th meters. We divide that by the light speed, and we get 0.5 times 10 to the 3rd seconds. Now, the question asks for the answer to be in minutes, so now we have to divide that by 60 seconds per minute. And now we can leave scientific notation and convert it to 500 divided by 60, which is 50 divided by 6, and we get a grand total of 8.3 minutes. That's about 8 minutes and 20 seconds it takes for light from the sun to reach the Earth. Next question. WUFT and NPR station broadcast at 89.1 megahertz from the University of Florida in Gainesville. Go Gators! What is the length in meters of each radio wave that emanates from the WUFT radio tower? Round your answer to the nearest tenth. So we learned in the previous unit that speed is wavelength times frequency. The question asks for the wavelength, so we convert it to wavelength equals speed divided by the frequency. We're given a frequency. Megahertz means million hertz, so it's 89,100,000 hertz. Again, an awful lot of zeros. Let's convert that to scientific notation. 8.91 times 10 to the 7th hertz. And now we'll plug into the formula. The speed, again, is 3 times 10 to the 8th meters a second. The frequency is 8.91 times 10 to the 7th hertz. Do the division, we get 0.337 times 10 to the 1st meters, which equals 3.4 meters